Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman Irfan Bioma Yusof from class J4 EM1104M, and today I want to talk about my report on the experiment of hydrostatic forces on plane surfaces. So there are two objectives of conducting this experiment. First is to study the scale of the force of pressure and the center of pressure on partially submerged and fully submerged planes. And second is to set a contrast between experimental results and theoretical values. This is to prove our initial hypothesis of uh, experimental results being larger or smaller than theoretical values. Next, next we have the procedure. So how are we going to conduct the experiment uh, in just a smooth flow? Okay. First is the apparatus is placed and prepared on top of the bench, right? Second is then we have to make sure the apparatus is built properly, is installed properly, so that we can avoid errors. We can avoid we can avoid errors coming from faulty equipments, and we could have a more detailed and accurate result, right? Then apparatus is leveled through adjustable feet, facilitated using spirit level. Next, we also have counterweight. We adjust the counterweight to keep balance arm at horizontal, so it needs to be at a straight horizontal line. Next, the drain valve is closed and shut, so that when we pour water into it, the water will not just flow out. Okay. Next, we are starting to use weight. We start with 50-gram weight, which is placed on balance span, right? And then uh, when we use this weight, the quadrant will start to fall down, will start to immerse down. So what we have to do is we have to add water so that it will balance, we can balance it back out. Next, we are going to analyze and record these findings in a data sheet, which will then be used to construct a graph. Next is we will repeat step 6 and 7 with heavier weights. This is what I mentioned before. We are going to use much heavier weights to get different constant. So this is the constant that we are going to change throughout this experiment. And lastly is when we are finally done with our experiment, we are going to drain the water out by opening the B16 valve. So this is to give a better look at what we are going to do throughout this experiment. We have step 1 all up until step 9. So step 1 is of course to place the apparatus on the bench. Step 2 is making sure this apparatus is installed properly. Third is to adjust the adjustable feet using the spirit level. Okay, and we are going to uh, right where step 4 is we are going to adjust the counterweight to keep this balance arm at horizontal. Okay, then the step 5 is we pour water right after the drain valve is shut. Step 6 is we are going to place a 50-gram weight to give uh, yeah, we are going to place 50-gram weights, and then we pour more water to keep the balance arm at horizontal. Step 7 is we are going to record and analyze in a table. We are going to construct a table of data. We are going to, and then step 8 is to repeat the step 6 and 7 using heavier weights. And step 9 is we are going to drain the water out right after the experiment is finished. So what we have to look at now is the safety precautions in conducting lab experiment. So during the course of completing the experiment, we have to always wear closed-toe shoes and boots so that we won't injure our feet. Then we have to keep in mind that suitable attire at the lab is a must, where we have to use proper attire. We have to use maybe our faculty jacket. We we have to use gloves. We have to use goggles. Right, this is to prevent further and more serious injuries or damage to the surroundings and of course to ourselves. Third is of course to keep surroundings clean and neat by cleaning any spills on the floor to avoid accidents and injuries. So we are in this experiment, we are dealing with water, we are pouring water, we are draining water out. So accidents happen due to wet floor. So when we are draining water out, let's say we are draining the water out and the water spills down to the floor, maybe one of us will get tripped, will trip over the wet floor and causing serious injuries. So this three is something that is really crucial to get the most of our experiment. So this is the calculations where um, based on the theory in our lab sheets, uh, there's uh, there's calculations to find the resultant force. There's calculation to find the second moment experimental values, the second moment theoretical values. So this is what I've done. So that as you can see, uh, I did my calculation for all uh, the change constant, right? Whereas, for example, this one is d is equal to 0.046 meter for the depth of immersion. Then I'll go on to d is equals to 1.082 meters. So that's proof of what I've calculated, and I'm going to record this in the table. The next is my calculations of error, where second moment of theory is to be subtracted with the second moment of experimental value, and both will be divided with the second moment theoretical values, and it will be times by 100. An example of calculation there. So this is when I'm trying to calculate the hydrostatic resultant force for partial immersed phase. So for this constant, I'm using d is equal to 0.046 meters. For the depth of immersion, formula is equals to 4 F is equal to rho g times example of calculation there. So this is when I'm trying to calculate the hydrostatic resultant force for partial immersed surface. So for this constant, I'm using d is equal to 0.046 meters for the depth of immersion. The formula is equal to 4 F is equal to rho g times bd square over 2, and the values of example like density, gravity, and it's all given in the data, so it's a fixed value. I'm just going to fill in the blanks, and I'm going to come up with the answer there, which is F is equals to 0.7784 Newton. So that's our force, our resultant force. So this is what I've did with the data, where I record this data in a table, which as you can see here, and the depth of immersion, since we are doing an online lab, this I've used the set data tree as a finding here. So this partial, either it's partial immersion or full immersion, is already given by the data. So this is what I've did with the calculations. I just fill in the table here, and also I've come up with the error percentage. Right, so next is graph plotting and creation, which I've done using Microsoft Excel. So here I'm just going to fill in the table with resultant hydrostatic force, with also the second moment of experimental values, and also the second moment theoretical values. So I'm just going to just create a simple table, and then the rest I'm just going to fill in the values from the first data collected from using our initial weight all up until the final weight used. Just give me a second, and I'm just going to fill in the values. And next is what I'm going to do next is I'm going to take all the values I've recorded, and straight away did the graph using the scatter type graph. And I'm just going to just change the axis with the y-axis and x-axis, where y is the recording of both of second moment experimental and theoretical values, and y being the resultant force. So after the addition of values, right, so just give it a second here. This is data what this is data that I did. This is the graph that came out of the obtained data and values. So just going to edit with a bit of details there, like the topics, the title, and that's how I did my graph. This is the final look at the graph of results where the vertical axis, yes, which is y-axis, is the resultant hydrostatic force in measured in Newton, and the x-axis, being the horizontal axis, is my recording of second moment for both experimental and theoretical values. Right, this is the legend, where blue being the moment experimental and orange is the second moment theoretical value. Now to the discussion. Right, discussion is what I did with my group members, where the discussion question in the lab sheets is being answered here. Right, so this is my answers. As a conclusion, so the hydrostatic force acting on both partially and fully submerged vertical surface increases as the depth of immerse increases. So the hydrostatic force in the system increases as the center of pressure decreases. This is because the lower or the deeper we go, the higher the pressure becomes, since pressure is higher in deeper conditions. Right, so in application, the principle of hydrostatic is used for problems relating to pressure in deep water and high in atmosphere. So what I did is, this is a picture of a dam, a water dam, uh, where the deeper we go, right, where the deeper we go, the higher the pressure is. Right, so this is what hydrostatic pressure means in real life situation. So I think that is all from me. Thank you for spending your time. Assalamualaikum warahmatullahi wabarakatuh, and thank you.